Today, we will deploy a customer headside on a Kubernetes cluster. In our example, we will be using a GKE cluster to deploy our CE. And this CE will be connected to the distributed cloud console via internet and secure tunnels. The application will be exposed using Google Load Balancer. So the customer will make a request to the load balancer, and then it will be load balanced or will be forwarded to the application pod. So when a site is deployed as a pod on Kubernetes cluster, it acts as a Kubernetes ingress controller with built-in application security like web application firewall, API security, pod mitigation. So to create a Kubernetes site, there are prerequisites. First, you need to have a distributed cloud service account. You need at the minimum 4 virtual CPUs and 14 gigabytes of memory per node. And we do support AKS, EKS, GKE, OCP, and Minikube for deploying Kubernetes pods. This is how the workflow looks like. First, we will create a site token on the distributed cloud console. Then we will prepare a manifest file. And then after that, we will deploy a site as Kubernetes pod. To create the token, we'll go to the cloud and edge sites. And under manage site management, you can go to site tokens and you can create a token. For our deployment, we have already created a token. And now this token, you should save it for updating your manifest file. We will use this inside the manifest file. So this is how the manifest file looks like, and you can find it on gitlab.com/volterra.io. And this manifest file will create a namespace, service account, roles, and role bindings. And when you scroll down, there is a piece called config map, where we will put the cluster name, latitude and longitude. Latitude and longitude is used for connecting to the REs. And then in the end, we'll put the token value, which was generated in the previous section. So for this demo, we have already created the site, CE site. This is how it looks like. So if I go and get pods in Vest-System. So with this manifest, 6 pods were generated, and one pod Vir-0 has 16 containers, and these 16 containers are most of the containers that we use for control plane as well as for the data plane functions. We have also created application pod called star-ratings, and this application will be used for this demonstration. So let's go to the distributed cloud console and start configuring our HTTP load balancer for applying the security policies. So under distributed cloud, manage load balancer, we will create the origin pool. So when we hit add origin pool, give it a name, let's say star-demo, and then we will add the origin servers. There are multiple ways to add origin server. For example, public IP, public DNS name, IP address of origin on given site. There are multiple ways, but the way we're gonna use is to let CE discover service using Kubernetes service name. So let's find out the service name. In our case, the service name is star-ratings-app. And we will tell CE which namespace this app is in. So this service is in. So this is the service name dot the namespace name. Which site is it on and which network? So we have exposed it on the outside network. And the service is exposed on port 8080. And let's update 443 to 8080. And we're gonna select a basic HTTP health check, which was already created, and save and exit. So as soon as we do that, it created an origin pool with the pool members of the star rating app. Now let's go and create the HTTP load balancer. Let's go here, give it a name, star-demo is the name, and domains, I'm gonna use star dot. So I own this kundalkanti.com domain, so we're gonna use this. Plus what we're gonna do is we will -demo. We will add another entry with default in the end. This means when HTTP load balancer creates an object, it will create a service with within the default namespace with the name service-demo, and that service will be type nodeboard. We'll see that right now the type nodeboard service does not exist for with the name star-demo, but as soon as we complete the HTTP load balancer configuration, a new service will be created. We'll create HTTP load balancer. From origin pools, we'll select the demo origin pool that we just created, and we will enable these security policies, especially the web application firewall policy afterwards. Now this is where we make some changes on where should we or will be exposing our application. So by default, we expose it on internet, meaning our REs will expose the application, and our REs, and we will be managing your DNS on your behalf. But in our case, we will go custom because we want to expose application via Google load balancers, and we will advertise it on a site. Save and exit. As soon as we save and CE receives the configuration, a new service with the type nodeboard is created. Now the type nodeboard is created, and now we want to expose this on the internet. There are two ways to expose it on the internet. First, we create a load balancer manually, a layer 7 HTTP load balancer, or we edit this service and change the type from nodeboard to load balancer, and that way Google will create load balancer for us. So let's go ahead and edit the service star-demo and change this type to load balancer. So as soon as we did that, it started creating the load balancer, which gonna take few seconds. So a new load balancer got created with one target pool. And if we get in, we can find the public IP. So this is my public IP. All right, let's do wget on this public IP. And oops, we got the error message. And this error message is coming because CE would not allow the request until a host header is added to the request. So let's go and add a host header to this request. Let's change curl and send the host header as well. As soon as we added the host header, we got the landing page. I already added entry in the domain. So let's go and start and type this address inside the browser. All right, there you go. So we got the landing page, and our app is working. It's so easy to expose the app using CE. And now let's apply some security policies to it. So if I go here and I send some attacks, so you can see for SQL injection, threat campaign, and CVEs, our application is vulnerable. So what we will do is we'll go back and we'll edit the configuration, and we'll add the web application firewall. So either you can create a new firewall or you can apply an existing one. So we will apply the existing web application firewall, save and exit, and let's rerun the test. As soon as we do that, it's going to take a few seconds. Yeah, there you go. So right now our attacks are being blocked by the web application firewall. And if you go here and you can also see the attacks as well. So this is our dashboard, and you can see all the security events that happen to this particular proxy. So you can see the top paths and security events, top attack types, and WAAP signatures that were hit because of the vulnerabilities that were sent. Plus, you can also see the security events, what was requested, and what methods were used. You can also view the performance metrics here as well. So you can go and check these performance metrics. So it's so easy to apply the security policies, to deploy the site inside the Kubernetes first, then to expose the application using Google Load Balancer, and then apply the security controls right here, right? Everything is dynamic, and it happens with the click of button. With the single pane of glass, you can start seeing the matrix or your security performance as well as security matrix on the cloud console right away as soon as it gets applied.